Hey, what's up, Blackhawks? Mr. Klein coming at you to talk a little bit more about how to use your calculator. We're on Unit 2, Lesson 3, solving function problems with the TI-84 calculator. All right, so I've said it before, but I can't emphasize this enough. Super important that you turn the calculator on. So let's do that. And we're going to navigate to the y equals, and I'd like you to type this function in right here at y1. Pause the video if you need to. Okay. Goal. I want to teach you how to find the domain and the range, the zeros, the increasing and the decreasing intervals using the calculator. The first step is to find a good window. It never hurts to start by going zoom and then just zoom standard. So zoom 6. Okay. And we can see that there's a little chunk of the graph and it's restricted. And we'd like to get a better idea of what's going on here. So a couple options for zooming. I'm going to go with the Z box, which I think you saw in the last lesson, but if you haven't, I'm going to go over it. Hit zoom box, and then let's suppose that I want the window to start with this as the upper left-hand corner right there. I'm going to hit the enter button. Enter right here. And then the cursor should change. I'm going to move using the arrow keys down and to the right. And that looks pretty good. Once I get a window that I like, I'm going to hit the enter button a second time. And there's our function. I'm going to ask you to draw a picture of it. Okay. Now, to answer most of these questions, there's three really important points that we need to identify in the graph. The first is the left endpoint. The second is the maximum. And the third is the right endpoint. Okay. Let's start with the endpoints. Those are probably a little bit easier. I'm going to hit the trace button. When you hit trace, it's going to move along the function. You're going to see the x and the y values. Sometimes this works, sometimes it doesn't. I'm going to move as far as I can to the left. And eventually notice that the y is going to disappear. So the leftmost point is pretty close to here. Now, that's not the actual point. The actual point is going to be at 1. And I can see it's going to be at 1 because see how 1 is the smallest number that we can plug into this term right here. So to find the y value at 1, I'm going to go second calc value. Once again, second calc value. And then down here in the lower left-hand corner, I'm going to be prompted to give it a value. I'm going to say, let's make x equal to 1. I'm going to hit enter, and bada boom, bada bing. It turns out that this point is 1, comma, 0.208. 3 decimal places today. For the other one over here, we could use the trace feature and try to get as close as we want. Or we could notice that it's at 1, 2, 3, 4, 5, 6. And 6 kind of tracks. It makes sense because if you look at this value right here, see that if you plugged anything bigger than 6 in, even a 6.1, you're going to get a negative value inside the square root. So this one's going to be at 6. And I am going to use the second calc value feature once again to find out what that point is at 6. Turns out this one is 6, comma, negative 2.028. Okay, now let's go to the maximum. Start with what I don't want you to do. I don't want you to hit the trace button and then move your cursor until it looks like it is near the maximum. What I want you to do instead is hit second calc, and you'll notice that there's a maximum feature. It's number 4. So you're going to hit number 4. And then the calculator is going to ask you for some help finding the maximum. What you want to do, maximum is about right here, is it says a left bound. So I want you to move so that you are clearly to the left of where the maximum happens, like right here. Then you're going to hit enter. And you'll see a vertical line appear, and that's saying that the calculator is only going to look to this side of the line. Now I'm going to ask you for a right bound. So come back to where the maximum is, or looks, and then move clearly to the right of it. Hit enter again. And then it's going to ask you for a guess. and you're going to move your cursor as close as you can to where you think the maximum is, and you're going to hit enter, and then the calculator is going to determine it for you. So this is the point 2.538, comma 1.562. All right, so let's talk about what information we can get from that. First, we can get the domain, because the domain is going to be everything from this number to this number. And notice that both of these x values have y values with them. That means that they are included, right? You want the hard brackets. So our domain is going to be 1 to 6. Range. Range is moving in the y direction. So the lowest y value that I have is right here, and the highest y value is right here. And so we're going to go from this y value to this y value. Therefore, our answer to range is going to be from negative 2.028 to 1.562. All right, I'm going to skip zeros for just a minute. And let's go to increasing interval. So the increasing interval is going to be from here to here. So we would say that is from 1 to 2.538. Generally, I use soft parentheses when we're talking about increasing and decreasing, but it doesn't make a big difference. The decreasing interval is over here, so that would be from where x is 2.538 until 6. Again, this is anytime I ask you about increasing or decreasing, that means you need to state the x values. The last thing I need to show you how to find is the 0. And the 0 would be this point right here, or on my graph. This point where we know that the y value is 0. And the way that you can calculate that is by going back to our buddy second calc, number 2. So calc 0, now you're going to help the calculator find it. Very similar to what we did with the maximum. You're going to choose a value that is a little bit to the left of this 0. So maybe up here. And then something that is a little bit to the right of this 0, right there. And then you're going to make a guess. And it's going to tell you that this point right here is 5.413. Therefore, your 0 is going to be x equals 5.413. Quick way that you can check that, if you wanted to, I'm going to quit out of here for a second, is you could hit second trace y1. Once again, second trace y1, and then enter the number in, 5.413. You should get something really close to 0, like this, which this number is actually negative 0.00009. Right, that's what the negative 5 is meaning. Like move the decimal place over 5 spots. So that's practically 0. Okay, moving along to number 2. First thing I want to make you guys aware of is that in your calculator, you don't have to get rid of the equation from number 1 to do number 2. So let's type number 2 into y2. I'm going to go math, number, absolute value, 4x minus 3 minus math, cube root of x. And then the problem says that we only want the region where x is greater than or equal to 0. So division. Now remember that that division sign is just a separator. We're not actually dividing anything. We are telling the calculator this is where the inequality starts. And we're going to enter parentheses. X is greater than or equal to. You find greater than or equal to right here under the button that says test. So second test. Screen will look like this. Grab number 4, 0, and parenthesis. And then I'm going to go back to a zoom standard. So zoom 6. Oh, and most important part before I do that, I don't want to see this graph, right? I can turn this graph off by moving my cursor to the equal sign and then hitting an enter. So see how right now the only one that's highlighted is number 2. That's the only graph I'm going to see when I hit zoom and then 6. And because I entered the inequality correctly, it's only showing me where y is 0 or greater. I'm going to zoom in on a little bit on that. I'm going to use the zoom box again. So up to about right here. There's my graph. And just like we did on the last one, I'd like you to draw a picture. Ba-boom. Ba-boom. And there is our graph. We can tell that it's going off to infinity in this direction. All right, so we need a few points. The first point we need is right here. That would be when x is 0, the y value is, second value, 3. Okay. Next thing, there is no right endpoint, so we just need to now find the minimum, and we're going to get the minimum by going second calc, minimum. Let's see, our minimum is right about there. It's between 0 and 1, so I'm going to move to the left of it, and then I'm going to, there's our minimum right there. I'm going to move to the right of it, and then I'm going to make a guess. And the calculator is going to tell me it is at this number, which should be 0.75. Look how close that is. Sometimes the calculator rounds things in a way that is going to look a little strange to you, like this. In that case, you can be reassured that it's actually 0.75. Okay, so now that we know those 2 points, that should give us the domain and the range. Our domain is going to be from 0 to infinity. Goes forever in this direction. Our range is going to be everything bigger than that number. So our range will go from negative 0.910 to infinity. Our increasing interval is going to be everything on this side of 0.75. So from 0.75 to infinity. And our decreasing interval is going to be everything from 0 to 0.75. Finally, we need to find the zeros. You'll see that there are 2 of them this time. Here's the first one. Here's the second one. Okay, now you can see why the calculator asks you for the bounds. I'm going to put a left bound right here. Now my right bound, it has to be somewhere around here. If I put it way over here, you're going to be in trouble. The calculator is not going to be able to tell which one of those zeros you're looking for. So you want to put it maybe somewhere in this neighborhood and then hit your guess. And there's our first answer, 0.546. And our second one will be second calc, 0. Left bound is somewhere around here. Right bound is on the other side. Notice that the region, once again, only captures one of the zeros. I hit enter. And, oh, that one is right at 1. Cool. All right. So there's a little bit of calculator school. I want you to complete this problem right here and then check your work with your teacher.